How does an email find its way across the globe in mere seconds? Today, we dive into the fascinating world of switched and IP networks. Imagine a vast web of connections, a network where information zips from one point to another, forming the backbone of our digital age. Computer networks, in their various forms, are crucial for everything from sending a quick chat message to streaming your favorite show. At the heart of these networks lie two key players: switched and IP networks. Switched networks, think of them as efficient traffic managers on a local scale, directing data precisely and securely within a network. They ensure that the communication between your computer and your office server, for example, is swift and uninterrupted. On the other hand, IP networks are the globetrotters of digital communication. They are responsible for sending your data across cities, countries, and continents, making sure that your email reaches its destination, whether it's next door or halfway around the world. Let's start by unraveling the intricacies of switched networks. Imagine a web of roads where each pathway is clear and traffic flows smoothly. This is quite akin to the world of switched networks, a fundamental concept in the realm of computer networking. Switched networks are built around the principle of packet switching technology, where data packets are the vehicles navigating these clear pathways. Each packet contains bits of data, which are sent to their destination via the most efficient route possible, avoiding congestion and ensuring that the data arrives quickly. The architecture of a switched network typically employs either a star or mesh topology. In a star topology, all devices are connected to a central switch. If one device wants to communicate with another, the data travels to the switch, which then directs it to the destination device. This setup minimizes the chance of data collision and maximizes efficiency. Mesh topology, on the other hand, allows for devices to be interconnected in a more decentralized manner. Each device has the potential to connect to multiple other devices, creating a robust network where even if one connection fails, others can take over, ensuring uninterrupted data flow. At the heart of these switched networks are the switches themselves, which maintain a forwarding table. This table is crucial as it holds the information necessary to decide where the data packets need to go. Each device connected to the switch is identified by a unique identifier known as the Media Access Control or MAC address. When a packet arrives at a switch, the switch checks its forwarding table, matches the MAC address, and forwards the packet directly to the corresponding device. This process is remarkably efficient and reduces the chance of data being sent to unnecessary destinations. Furthermore, because switches create dedicated connections between sending and receiving devices, they eliminate unnecessary traffic, which greatly enhances network performance and security. Each conversation between devices is effectively isolated, which also mitigates potential eavesdropping from other devices on the network. With dedicated pathways for each communication, switched networks ensure efficient data flow. Next, let's understand their benefits in more detail. Why opt for switched networks? The reasons are numerous and compelling. Imagine a network where every device enjoys its very own private communication line without any overheard conversations or unnecessary delays. That's the reality with switched networks, thanks to something called dedicated bandwidth. Each connection between a switch and a device is like a private chat room where only those two can communicate. This setup drastically reduces network congestion and enhances the performance of each device. Now let's talk scalability. As businesses grow, so too does the number of devices they rely on. Switched networks shine here because they handle additions smoothly. Adding new devices is as simple as connecting them to a switch, and the network scales without a hiccup. This means whether a company has 10 employees or 10,000, everyone can stay connected without degrading the system's overall efficiency. And when it comes to security, switched networks provide a robust defense. Unlike older shared media networks, where all devices share the same communication line, switches create separate collision domains. Each port on a switch is like a unique pathway, making it incredibly difficult for potential eavesdroppers to capture data from other ports. This architecture significantly reduces risks, such as packet sniffing and data theft. Examples of switched networks in action include Ethernet LANs, commonly found in offices, schools, and homes. These networks use Ethernet switches to ensure that data flows smoothly and securely between connected devices. Switched networks are not just about connectivity, they're about efficient and secure connectivity. Now let's shift gears to IP networks. While switched networks handle local traffic, IP networks break boundaries. IP networks, those intricate webs that span our globe, rely on the Internet Protocol Suite. This protocol suite is the essential set of rules and procedures that dictate how data is sent and received over the Internet and other network systems. It's what allows your smartphone in New York to send a photo to a friend's laptop in Tokyo. Let's talk topologies, the layouts that determine how network elements interact. In IP networks, these can vary widely. There's the star topology, where each device is connected to a central hub, simplifying management, but creating a single point of failure. Then there's the mesh topology, offering robust connections with devices interconnected in a lattice-like structure, ideal for ensuring there's always a path for data, even if one link goes down. Don't forget the bus topology, where all devices share a common backbone to communicate, and the ring topology, where data travels in one direction from one device to another until it returns to the source. Central to the operation of an IP network are the IP addresses, unique identifiers assigned to each device. These addresses ensure that the data packets find their way to the correct destinations. When you send an email or stream a video, your data is packaged into IP packets, which travel across various networks guided by routers. These routers are like the traffic cops of the network world, examining the destination IP addresses of packets and directing them along the best route possible. The dynamic nature of IP networks comes from their ability to route data through interconnected networks, regardless of the physical and logical differences between them. This flexibility and complexity are what enable your device to connect not just to another device in the same room, but to millions across the world. IP networks are the backbone of global connectivity, but what makes them so advantageous? Connecting across continents is no small feat. IP networks make it possible. Imagine a world where you can send an email from New York to Tokyo in a blink of an eye, or stream a live concert from London while sitting in your living room in Sydney. This is the reality made possible by IP networks, which are the backbone of global connectivity. They allow devices to communicate across diverse networks and geographical boundaries, ensuring that you can connect with anyone, anywhere in the world, at any time. One of the most remarkable features of IP networks is their flexibility. They support a wide array of services and applications, from simple data transfers to complex voice and video communications, and even multimedia streaming. This adaptability makes IP networks indispensable in today's digitally driven world, where the variety and volume of data transmitted over the internet continue to grow exponentially. Furthermore, scalability is another significant advantage of IP networks. Whether it's a small local area network in a home, or a vast wide area network used by a multinational corporation, IP networks can expand to accommodate an increasing number of devices and data traffic without compromising performance. This scalability ensures that as businesses grow and technologies evolve, the network can grow and adapt seamlessly. Examples of IP networks include the Internet, which connects millions of devices worldwide, enterprise networks that facilitate internal and external corporate communications, and virtual private networks, or VPNs, which provide secure connections for users. From streaming your favorite show to managing multinational business operations, IP networks are crucial. Let's summarize what we've learned. Today, we've navigated through the complex but fascinating world of switched and IP networks. In our exploration, we first delved into the realm of switched networks. These networks operate using network switches that employ packet switching technology to ensure data is efficiently directed from one device to another. Each switch acts as a controller, allowing devices to connect in a network using either a star or mesh topology. This setup provides dedicated bandwidth to each connection, significantly minimizing congestion and enhancing overall network performance. We discovered that switched networks are not only scalable, accommodating a growing number of devices seamlessly, but also offer enhanced security. Each switch port creates a separate collision domain, which drastically reduces the risks associated with eavesdropping and packet sniffing. Examples like Ethernet LANs, where devices are interconnected through Ethernet switches, illustrate how switched networks are optimally used for local communication within a single local area network. Transitioning to IP networks, we uncovered that these are governed by the Internet Protocol Suite and utilize IP addresses to identify and connect devices over a network. Unlike switched networks, IP networks can span a diverse range of topologies such as star, mesh, bus, and ring. This flexibility supports various data transmission services, including voice and video communications and multimedia streaming across interconnected networks. The strength of IP networks lies in their global connectivity capability, enabling devices to communicate across different networks and vast geographical areas. This scalability makes IP networks indispensable for not only local area networks, but also wide area networks and the Internet, the largest IP network connecting millions of devices worldwide. Both switched and IP networks are foundational to our modern communication infrastructure. Each serves distinct yet complementary roles, ensuring robust, secure, and efficient data transfer across both localized and global stages. Understanding these networks enriches our appreciation of the digital world's backbone. Thanks for joining this journey into the arteries of our connected lives.